Thank you, Dr. Watson. Thank you all. Thank you, Catherine, for your inspiring words this morning. Today I come here with emotion. We're full of emotion. I want to talk about emotion in my presentation this morning. There will be a clicker, I imagine.
It was here.
Or is it under here?
No, it disappeared.
Oh, there it is.
Oh, you're right.
So the emotion, I come with a little bit of jealousy, which is an emotion, because for nearly 2 decades I've been talking about how much I love data science, machine learning, data mining, and when I first got really passionate about it, about 2 decades into my career as an astrophysicist, which is that moment was about 20 years ago, I always was telling people I want to teach data mining to school kids. And then I heard yesterday from Peter Tong and Neil Whitehead how they're doing these wonderful things with elementary school kids, middle school kids, high school kids, and I am so darn jealous of what they're doing. They're actually doing it, and I always had this vision that it would require something like Legos because it's colors and shapes, and darn it if that's not exactly what they're doing. Okay. So the message this morning is data literacy for all. It's really about data science for everyone. And it's not so much the data science as the data literacy that I'm focusing on this morning, because it's really another literacy in the same way we have reading and writing and quantitative numeric literacy. So I often tell people, in this country we say we want to teach the 3 R's to our kids, the writing, reading, arithmetic. Play on words there. And I always say, well, we need to have the 4 R's, writing, reading, arithmetic, and R. Now, I don't necessarily mean we teach R coding at kindergarten level, but the concepts of computational literacy, computational thinking, data literacy, data thinking. And so I challenged people last night at the reception if they could spell R. No one got it right. Is that true? Those of you who were standing next to me last night, remember? The way you spell R is capital R. Never mind. Anyway, so we're talking about bringing data to everyone, bringing data to action. That's the message this morning. And I decided to use a marketing funnel. So maybe you've been watching the little slides go by as you're eating your breakfast this morning, and there was a cartoon about the marketing funnel, and someone's talking to a committee about their marketing funnel and their marketing campaign. And of course, Alexa is listening in, as Alexa always does, and said you can find funnel cake at this store like 2 miles from here. Okay, so I sort of missed the message there. So I decided to use this as sort of my metaphor for my outline this morning: awareness, consideration, conversion, loyalty, and advocacy. Because I really feel like that's sort of the message I'm trying to convey here. Is the first thing around data literacy is to build people awareness of it, then have them consider, why it matters to them, matters to their world, matters to their career, and then you get them to convert. That is, they actually buy it from you, so to speak. But at a point, they don't just buy it, so to speak, but they become loyal to it. That is, they realize this is what they need to do. This is the way they need to do things. And then at the last phase of the marketing funnel, again from the marketing world, is advocacy, where you become a fan in the marketplace for that brand, for that product. Okay, so when we reach that point of advocacy, where the people who are now doing this stuff around data become the big fans in the marketplace, in the world, to other students, to other colleagues, to other industries, to wherever they are, they become an advocate for it. They become a fan for it. Okay, and so they're passing on your message for you. Okay, so I want to use that metaphor as I go through this morning. And so when I get to each point in the presentation and another step in this outline, you'll see the word there, but at the top of the screen will be the more correct explanation of what's about to be brought before you. So we're now setting the stage here. This is the awareness phase. And so how we frame things really matters. So I saw this cartoon recently. So you see what's happening here. A young man staring at the crack in the wall. So he's looking at statistics and not really knowing what to do with that statistics. Sorry, Janet. But Janet teaches people statistics, so frames it differently. calls it machine learning. Frames it a little bit more, calls it AI, and all of a sudden there's a big audience in front of us. So I used this slide in a presentation I gave recently at the Northern Virginia Technology Council. And the title of my talk was How to Leverage AI versus Having AI Leverage Us. And so I had a little arrow on the slide there pointing to the audience that we're being leveraged to pay attention to this. Okay, so AI is leveraging the world to pay attention to what we're doing. But how can we leverage the power of AI versus just having it leverage our audience to pay attention to us? So data science really matters. So I wrote this thing 4 years ago. I called it my data science declaration. I love plays on words, so it's a little bit of play on words here. Now is the time to begin thinking of data science as a profession, not a job, as a corporate culture, not a corporate agenda, as a strategy, not a stratagem, as a core competency, not a course, and as a way of doing things, not a thing to do. So if I were to modify that slightly today, I would add this additional phrase: data competency is a way of thinking, i.e. data literacy, is a way of thinking, not a thing to think about. Okay, so it's really a way of business, a way of being, a way of doing whatever we do in the world. So it's really is for everyone. It's not just for data scientists. So a talk I gave a few years ago, in 2014, I talked about sort of the three dimensions of data science and education. So one of those dimensions, which is actually number 2 on the list, right? I should have put that at the top. It was sort of the way we started doing data science. So we at George Mason University and the College of Science started the world's first bachelor's degree program in 2006. So we were pretty alone in the world. There weren't too many such programs, and now there's literally hundreds of graduate and undergraduate programs in data science. So we're training people to be data scientists, okay? So that's an education in big data and data science. But also, number 1 there, we knew all along, and this is what has been my passion since those 20 years when I sort of got bitten by this bug when I was working with data systems at NASA, is that we need to have this incorporated in all education, in all learning settings, in all courses, whether it's history, social studies, health, medicine, your phys ed course. There's data, there's digital signals and digital processing and pattern recognition and pattern detection and all kinds of cool things happening in every discipline in the world today. So this needs to be incorporated in education, not just for data scientists. And then the third one on the list, which ties in a bit here to the Big Data Analytics and Education conference we're at, is learning analytics. That is using data for education, how to improve education, how to improve online learning, how to improve student retention and student recruiting and so on, using the data in your education system to improve your education process. All right, so all those things which I talked about in that talk 5 years ago are still valid today. Thank you for this wonderful conference. Thank you for Elena for organizing this for so many years and bringing me here. So it's this in education, by education, and for education is still very relevant to what we're doing today. So data literacy is a way of thinking about numbers and measurements of things. Okay, so that's my one of my granddaughters there on her 3rd birthday. With the big 3 on her chest there. And of course, as Commander Data, one of my heroes, Commander Data says, those who with the most birthdays live the longest. So numbers convey a lot, okay? So it's not just numbers, they're measurements, but they're measurements of things, they're measurements of patterns in the world. So when people often ask me, what do I think of, how do I define big data? There's all kinds of definitions of big data, most of which I hate. For example, the one in Wikipedia, which may have been changed, but I haven't even bothered to check. But in early days, big data was defined as more data than you previously were able to handle. Well, the first time the Romans took a census of the world several thousand years ago, and counted the number of people and their various remote townships, so that was more data than they had ever handled before. I mean, I would not call that big data. What I call big data is we now have insights, we have measurements on many, many, many dimensions of everything in our world, whether it's people or students or healthcare or machines or athletes or your supply chain or your manufacturing plant or anything. We have all these different data sources, data insights, 360 view if you want to call it that, on just about everything in the world. that is a completely different thing than we've ever had before. We now have all these different ways of looking at every single thing in the world. All right, and it's not about the volume, it's about that variety that really makes it really interesting. So when I talk about data literacy, it'll include statistics literacy. So as a former professor, I need to start with a quiz this morning. Okay? So bear with me here, and you can participate in this quiz. You don't have to speak your answer out loud. But let's just start with this quiz. So this is just a little warm-up for us to kickstart us here on this literacy thing this morning. Suppose that a survey, this is all made up, suppose that a survey finds that 10% of people believe that product X is bad for you. All right, so there's a company out there that produces product X. The survey, they found out that 10% of people think this product is bad for them. Okay, so they launched a national advertising campaign about this, or maybe there's a way it's written there. Someone else wants to sort of help make you be more aware of the dangers of product X. Okay, that's how it's worded there. Okay, so they do this national campaign to increase the awareness of the dangers of product X. So after this national campaign, as true statistical testing would go, they do another survey to determine the benefit, the outcome of this campaign. And so the national media report after the survey announced the following, which is written in the green font there. Following a national advertising campaign, the number of people who now believe product X is bad for you has increased by 90%. So your quiz this morning is, what is the percentage of people that now believe product X is bad for you? So you don't have to speak it out loud. But how many people got 19%? How many people got 100%? How many people got something else? Well, guess what? The answer probably is 19% if they were speaking in ways that we think, as statistically and data literate audience we have this morning. Or maybe they said it that way in such a way, knowing that people are only pay attention to sound bites in our society today and are not statistical and data literate, and they would immediately jump to the conclusion 10 plus 90 is 100, so now 100 people, 100% of the population thinks product X is bad for you. Okay? So knowing full well that that's not the truth, but they say it in such a way that people with short attention spans and who don't understand the statistics and numbers will just do the addition in their head. Because most people won't do the 90% of 10 added to 10 gets 19. They will just do 10 plus 90 equals 100. Right? Or maybe the actual result is 100% for real, and they just didn't report it very well in the national report. So all those are possibilities, but I challenge you to think that there's probably another interpretation of this survey result. So we go back to the original statement, and I have it there again in green. The only difference is I've underlined some words, but it's the exact same statement I had on the previous slide. And the focus on the fact that it says the number of people has increased by 90%. So what if in the original survey they asked 100 people and 10 said it's bad for you, so that's 10%. In the next survey they asked 10 million people and only 19 said it's bad for you. So the number of people who say it's bad for you has increased by 90%. How to lie with statistics. I taught a course on data ethics at the university as part of our data science program, and this is how I started my semester, with this quiz. Okay, and believe me, most people did not get 19%. Most of them were very confused by the question, but those who were thinking got 19%. But I point out the fact that how you word it can really change the interpretation. So statistics and data literacy really matters. And this famous author, H.G. Wells, who wrote Time Machine and Travel to the Moon, or what's that, Mission to the Moon? World. He wrote, statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Okay, that was 116 years ago, and that day is definitely here now. Somebody else wrote more recently, it is now beyond any doubt that cigarettes are the biggest cause of statistics. Anyway. So data is everywhere. The importance of thinking about data and literacy the literacies around data are very important. So let's talk about the steps toward data literacy. Let's consider this. How would we approach this if you're talking to an audience, if you're talking to your grandmother, if you're talking to someone who's not getting this, or if we're just talking to our colleagues who may not quite understand yet what we're doing, which is surprising considering how far into this, this data transformation we've been into. And I always like to start with this story, and that is what we got ourselves in this situation of big data for one very simple reason, because we are very curious creatures. Human beings are very curious creatures. Ever since we came out of the first cave, we've explored our world and saw things and tried to understand those things. We are all born scientists. This is why I believe in teaching data mining to school kids is so easy to do, and it's already been demonstrated, and as we heard yesterday, is because children are very curious creatures. Humans are very curious creatures. We're always testing things, experimenting things. We do pattern recognition and pattern detection naturally. Children come out of the womb, they recognize the voice of their parents, they recognize the face of their parents. The first cavemen, when they came out of the cave and they saw an animal in front of them, that was pattern detection. Then they had to figure out, is this animal going to eat me for lunch or am I going to have it for lunch? Pattern recognition. That was important because the wrong decision, you would die. Your survival depended upon making the correct decision at that moment. So these are very natural things. And how do you find out? How do you classify that animal or that event or that thing or that patient or that student or that whatever? We collect data to test a hypothesis of what we think that thing is. So we collect data to answer our questions. And as all good scientists know, as you collect data and run an experiment, you end up with more questions, which leads to more experiments, which leads to more data collection, which leads to more questions, which leads to more experimentation and more data collection, which leads to more questions. Well, the number of questions you ask is proportional to the amount of data you're staring at. Therefore, the new data you collect is proportional to the amount of data you collect. And since the rate of change of a function proportional to itself defines an exponential, that's why we end up in an exponential growth curve, which is this unbelievably rapid, wait a minute, it's sort of way down at the bottom of my chart here. This unbelievably not so rapid growth curve, which everyone calls the exponential growth curve, is actually not the problem. Data volume is not the problem. We can handle data volume. We got cloud, we got all kinds of stuff, all right? There's more storage on my iPhone this morning that I got for free, 99 cents a month. There's more storage on my iPhone this morning by a factor of about 1,000 than the $35,000 hard drive I had to write a proposal for to NASA when I was working on the Hubble project. I wrote a proposal for $38,000 for a 1 gigabyte hard drive to store my data. Hello, the world has changed, right? So we now have the capacity to store it. That's not the problem. The problem is all the ways you can combine the data, all the ways you can put the different pieces together. That's how we define knowledge. It's the synthesis of bits of information, okay? So how do you classify a dog or a cat? We heard these stories yesterday about misclassification and deep fakes and generative adversarial networks. You change some little thing in the image, all of a sudden it gets it wrong because there's all these features that are combined in a certain way that enable us to classify something. And if the algorithm is building a model based on all these features and you tweak one of them that the human eye can't even detect, you can fool an algorithm into classifying something incorrectly. And it's not because it's not a picture of a dog and it says it's a cat. It really is still a picture of a dog, even though it says it's a cat. It's because it's using some feature and all these combinations of features to get it wrong. So it's the combinations that matter. So linear growth is like 2 times x, as shown here, exponential 2 to the x, and combinatorial growth is all those combinations, which is x factorial, which is like x to the x. That's why this is called my holy shoot graph. It's the combinations that really matter. Okay, so part of data literacy is understanding those kinds of things about data. It's not just the volume that's important, it's all those combinations of things. It's the variety of things that make them special, make them different, make them informative, help us to make decisions based upon all those features of things. So it's not about all these algorithms and all this stuff that makes the data unicorn so hard to find, right? So going back to my three parts of data in education, data for education, by education, and in education, yes, we do need to train data scientists, formal professional data scientists, all right? But that's not what this talk is about. It's not about that. It's about incorporating this stuff in a broader context. So here's one of those Venn diagrams that got everybody talking about the data unicorn. Because back, Drew Conway drew this 6 years ago and said a data scientist is this person who knows how to code like nobody else in the world, who knows all about data and statistics and data management like nobody else in the world, and they know your business inside and out in the domain like nobody else, all right? So they're a medical doctor, a PhD statistician, and the world's leading coder all in one. Where is that person? Can you please find me that person? Okay. There is no such person. Let's get real about this. The real thing that matters is that we can communicate with the domain experts. Yeah, you may be in two of these circles, but probably unlikely you're at the intersection of the three circles. Okay, so what we're teaching data scientists, formal professional data scientists, the formal part of it is focusing more on the hacking skills, if you want to call it the coding skills, and the statistics and data knowledge. We're not giving them PhDs in medicine or PhDs in manufacturing or PhDs in sociology at the same time. So we need to be able to communicate and work with and collaborate with those domain experts. So the real sweet spot is where the communication and collaboration happens with those people who have this essential expertise along with the people who have the coding and statistics and data expertise. And again, you can be in different places in this diagram. I'm not saying it's only this way, but to find one single person who has all of this, that's the hard part. So what we're finding in our organization at Booz Allen Hamilton is very hard to find domain experts to work with our clients, our federal clients, who have the domain expertise of a national security client or a DoD client or a National Institutes of Health client or a veterans client, a new hire who understands that client space, who understands the data, understands the needs, understands the services and products and things they're doing for their stakeholders, and at the same time know all the data science stuff. We can find people who know data science stuff, and we can find people who know this domain. So we need to get real about the fact that we need to maybe train those who have the domain expertise into data science, the skills of data science, so they can do that at least to the data literacy point. They can have more substantial conversations with those who are now in those upper circles. So data literacy, again, is not about the algorithms and the PhD in machine learning and statistics. It's really being able to read, work with, analyze, and argue with data. Okay, so I gave this definition in a talk once, and some people said, "Oh, you're teaching people to argue?" No, don't get me wrong here. This is more from from a decision support perspective. How do you argue for your case so that you can convince someone to make a decision or take an action? Okay, so we can work with data to do that. We know how to read data, work with data, analyze data, and make the argument, tell the data story. And I'm going to get to data storytelling soon. Believe me, that's my most favorite topic here. So this is what data literacy includes. It includes these things. And so what we want to do then is we want to teach people how to use data correctly. But part two of that, the flip side of that, the yin and yang of data literacy, the flip side of that is how to use data ethically. So data literacy includes both these things, understanding how to use it correctly and how to use it ethically. Okay, so correctly sort of subsumes ethically also, but I wanted to call it out separately. So one of those is data science, and one of those is more the human side of knowing whether you're doing the correct thing ethically. Okay, so I don't know if you can read the cartoons here. I'll read them real fast here. So Dilbert's one of my favorite characters, and you all know Dilbert, right? So you know who the characters are in the play, okay? So Dilbert's the nerd, and the pointy-haired boss is the doofus, okay? Okay, so when you see doofus statements from the pointy-haired guy, that's because he's portrayed in these cartoons as that character in this drama that unfolds in three panels here. Okay, so this pointy-haired boss says, hey, we can use that CRS database to size the market. So Dilbert says, well, that data's wrong. So then the boss says, hey, we can use the SIBS database. And Dilbert says, well, that data is also wrong. So the boss says, well, can you average them? And snarky response from the nerd said, sure, I can multiply them too. So I've given this cartoon a few times in talks, and it dawned on me one day that there's actually a much deeper message here. That is, what is averaging? But it's reversion to the mean, right? So sometimes we average data to get closer to the truth. So maybe the boss was onto something here. Taking an average might not have been a bad idea, actually. So what about this multiplication? Well, Dilbert's one step ahead of the boss. He wasn't talking about an arithmetic mean, but a geometric mean. Think about that. Okay, so then we get to how to use data ethically. So the boss says, we have this gigantic database full of customer information, and Dilbert says, hey, we can use nonlinear math, data mining technology, optimize our retail channels. Boss says, hey, if that's the same thing as span, we're having a good meeting here. Okay. So if you torture your data long enough, it will confess to anything. So back in the day, if you had a rare event, a 1 in a million event, okay, 6 sigma event, you need to pay attention to that. It's either a data quality problem, a data processing problem, or your Nobel Prize weighting. So you really need to pay attention to a 6 sigma result, okay, that 1 in a million thing. But now that we have billions and trillions of data points, a 1 in a million thing will occur millions of times, just statistically. Okay, 6 sigma, 1 in a million. If you have a trillion things, you will see it a million times, okay? It's just a statistical fluctuation. It's not a meaningful thing, but you have to investigate these things to be aware of that, but don't run off and say, look what we found, if it's just a statistical fluctuation. So if you look at data, a lot of data, piles of data hard enough, you're gonna find all kinds of correlations. We saw some of these yesterday. I like these as well. I use these in my talks from Tyler Vigen. I actually met the guy once at a conference. It turns out he was a law student at Harvard. And of course, lawyers are empowered to use correlation in their arguments because they know that human beings will naturally go to causation. So they don't imply causation in their closing arguments. But the jury panel oftentimes will jump to causation when they hear about the correlation. Okay, so he discovered all these spurious correlations, put them up on a website. He now has a book. Anyway, so the number of people who drowned falling into pool correlates with films Nicolas Cage appeared in, or the number of worldwide non-commercial space launches correlates with the number of sociology doctorates awarded. I sort of like this one because even though this may look spurious, there might be a latent hidden variable there. That is, the increase of both of these might be correlated with the fact that we're going to Mars someday soon. Never mind. Anyway, I used to think that correlation implied causation. Then I took a statistics class. Now I don't. Oh, so it sounds like the class helped. Well, maybe. Another fun source of cartoons, the XKCD. If you're not familiar with it, check out XKCD. You'll just, as a data person, statistics person, you'll laugh all day long with these cartoons. Anyway, so data fallacies are everywhere. I'm not going to read this chart to you. There's the data fallacies everywhere. These slides will be available, so don't worry about trying to copy all this stuff down. You can follow the links to the things you see on these slides. So here's one example of a fallacy. Okay, so I normally tell this as a cartoon, and I wear 2 different colored socks on, but I'm not going to do that today. So the punchline has to do with looking at my socks and this joke, which I'm not going to bore you with. And I always wait for someone in the audience to laugh a little bit harder than everyone else in the room at my joke, which assuming someone will laugh at my joke. And I ask that person, why are you laughing so hard? And they'll say to me, because you have 2 different socks on. And then I will say, no, I don't. They're both the same size. Why is color more important than size? What makes you think that color is the most important feature of my socks? They're comfortable at the same size. Color has nothing to do with it. So we have all these cognitive biases where we think that a certain feature is the important thing when it is not. All right? We do this all the time. Now, in statistics, when you have more features and more structure in your data than your model fits, that's called bias. Underfitting is called bias. So if you have a distribution of data points that looks like a parabola and you fit a straight line to it, you use two parameters, a slope and an intercept, you have a two-parameter model, it does not capture the full structure of the data set. In statistics, we call that bias. We look at too few features to explain the full structure and complexity of the thing we're looking at. In human life, when we do that, we have a word for that. It's called bias. When you make a decision about a person based upon some physical characteristic, something that you don't see the full dimensionality of that person in job hiring or whatever. So bias, cognitive bias, is what we're busting now with all this high variety big data. So I say the era of big data is really about the end of demographics. We now have all these different perspectives and viewpoints on things that we never had before. We now have these multi-dimensional perspectives on things. So if we used to look at something, let's say in this cartoon diagram here from one direction, it looks like a single cloud of data points. But now we have a new dimension in which to look at it from the side, or from the bottom in this case, and it separates into two distinct clouds of data. There's more structure in the data than we ever saw before. Another example of this is this. Okay, so here's this, what's called in math, okay, a cylindrical, spherical, a circular cylinder. So we have this circular cylinder. So when looked at in projection from the blue side, it looks like a circle. So someone who's looking at this object, this thing, and the only data they have about it is from that perspective, they'll say it's a circle. I guarantee you it's a circle, and that is true. Then another person who has another collection of data looking at the same thing, the same person, the same event, the same process, the same behavior, will look at it from another perspective, let's say from the orange side, and that projects as a rectangle or a square. And they'll say, it's a rectangle. It's a rectangle. I guarantee you it's a rectangle. And that's the truth. That is true, not the truth. So both these statements are true, but they're not the truth. The truth lives in a hyperdimensional space that our big data collections are now letting us see more structure. So what we believe is true is true. From that perspective, it is a circle. From that perspective, it is a rectangle. But it is not the truth of the thing. Okay, so high variety data is a bias buster. It helps us to break down our biases because now we're seeing things from these perspectives we never saw before. So look at the two little blue plots on the upper half of the plot. So it's the same population of objects looked in one dimension. We see this data histogram. It looks like a single population. Then we look at it in another feature, and a data histogram of the distribution of values of that same population. It now separates into two populations. Same thing with the thing on the bottom. Okay, we looked at this. This actually is an astronomy example, but it doesn't matter what it is. We looked at this collection of objects in the lower left, and we saw this correlation, where it says not good. We found this correlation between two parameters, A and B, I'll just call them. And we think we have a single population here that has this particular property where A correlates with B. We now understand this system completely. We now think we know all about it. And in my field of research, this is a real true story. People thought they fully understood this system, and papers were written for a decade on this topic. And then people started collecting other data, parameters C and D, as I'll call them here. And all of a sudden, this thing broke into two separate populations. Wait a minute, we thought there was a single population here that had this A correlate with B property. Now there's two populations here. In fact, there's three populations because there's actually something between those two data clouds. Okay, so there was way more stuff going on than we ever believed because we were stuck in this sort of two-dimensional land, flat land, if you want to call it. Okay. So we're moving out of our flat land to seeing things in higher dimensions. So the idea is this type of messaging to people, why we're collecting all this data, not to steal their privacy and to ruin their lives, but to make them better, more objective, more evidence-based, better health, better education, better everything. Okay, so now that you've got people considering it, how do you convert people? You convert people because you're taking all this data and you're turning it into value and action. You're connecting the dots. Remember what I said about all the combinations? Finding the right ways of putting your data together to get the insights you need to take better actions and better decisions. Actionable intelligence. That's the real AI. Someone argued with me. I put together this chart. I called it the real AI. Accelerated, amplified, augmented, assisted, adaptable intelligence. And they said, isn't that kind of an oxymoron? The real artificial intelligence? So I said, okay, it's the real power of AI, or these things it does for you. There's nothing artificial about the things it does for you. It's really a misnomer, okay? The things it does for us are not artificial, okay? So you get people to say, yeah, I see, I may have become data literate, understanding the importance of the data collections, but now I see the value in it. I can discover patterns in data, clusters, segments, correlations, outliers, surprising things, unexpected things, even in sort of networks like social networks or any kind of linked graph network. Finding these relationships, even 2 or 3 or 6 degrees of separations of things that you'll never find in a relational database, but you'll find in a graph database. You'll start thinking about data in completely new ways. So you see little cartoon pictures talk about cluster discovery and outlier discovery, link discovery, but number 2 is my favorite, correlation discovery, because if you find a correlation between 2 parameters, let's say P1 and P3 in this plot up here, if you find a correlation between P1 and P3, then if you know P1, you can predict P3. So at the very least, it's dimension reduction, right? Because once you know P1, you don't need to measure P3 anymore. So we're always looking for ways to reduce the amount of data we got to stare at. So that's predictive power discovery. Correlation is predictive power discovery. And I'm not saying it's causation. It's just that you know when P1 is this, P3 is likely to be that. So it's predictive. But if suddenly that correlation changes somehow, like P3 versus P1, changes slope for data cloud 2. So data cloud 2 is some cluster, some class of behavior in this fake system I'm showing here, people, events, behaviors, whatever it is, machine operations, marketing, health diagnoses, it doesn't matter what it is. There's a change in the slope of the correlation at some point. Why is that? I don't know. Let's collect more data. As you collect more data, along comes parameter P2, which is maybe a parameter which you have some control over. It's a treatment variable, as we call it in statistics. If it's a treatment variable that is something you have control over, you can see the point where a particular value of P2 will change the slope of the P3 versus P1 relation. So if P3 is something you want to increase, like sales or customer satisfaction or health and well-being of someone, you can move it to a higher value of P3 by adjusting P2 to a place where you get that higher value. But if P3 is something you want to reduce, like risk or danger or losses, you know what to do with P2 to move it down to lower values of P3. So by adding extra dimensions beyond just the 2, high variety data again, you now have prescriptive power discovery. You can prescribe an outcome. I call that the killer asteroid moment, right? Every organization has a killer asteroid moment, not just astronomers. So if I tell you that we've measured the position of this asteroid in the sky, and we use Newtonian mechanics and predict in orbit, and we predict this asteroid is going to hit Earth and wipe out civilization, 12 noon next Tuesday, have a nice day, see you later, I'm off the stage now. You're going to call me back and say, wait, can't you do something about it? I said, oh, you don't just want a predictive model, you want a prescriptive model. Okay, why did you say so? Okay, so when we go to the doctor, we call it a prescription, right? Oh, you got this illness, you're going to die. Have a nice day, here's my bill. Wait, can't you do something? Oh, yeah, let me write you a prescription. Oh, this machine is going to fail. We predict this machine is going to fail. Can't you? And then you say, okay, let's let it fail. No, let's do something about it. Well, what can we do? Well, we looked at the data. If we reduce the operating speed or the operating temperature, or we don't use it quite as often in the shop, it'll have a longer life and it won't fail. Oh, you're talking about prescriptive action. And we have data to show that prescriptive action will work to reduce the likelihood of the killer asteroid moment. The patient dying, the machine failing, the employee leaving, all right, the batter striking out, think of Moneyball, okay? So everything has its killer asteroid moment, and that's determined by other dimensions of data beside the predictive model, but the prescriptive model. So we're moving up this ladder of going from description to prediction, prescription, to ultimately cognitive, where we start asking new questions of our data, okay? So all these levels of analytics maturity can all occur simultaneously. It's not like you go from one and then you forget about it. So are we describing things, are we predicting things, prescribing things, or actually looking for greater insights from our data? Okay, so I like to say to people that oftentimes people will confuse predictive and prescriptive. Hopefully I described them to indicate to you that they're two different things. So one way to say it is all the wordy stuff there. The other way to say it is in the short mathematical statements. Predictive is given x, find y. And prescriptive is given y, find x. So I don't know how many years of math you've had, but I've had quite a few, but I didn't really need all those years of math to know that those are two opposite statements. Given x, find y, given y, find x, okay? So what it is predictive is given this value for x, what's this outcome? That's a prediction. But I want it to be a better outcome. I want to achieve something better. How can I get that? So what do I need to do to get that? So given y, find x, okay? So as Confucius said, he was a predictive analytics philosopher who said, study your past to know your future. That's a perfect statement of supervised machine learning, by the way. Study your past to know your future. I had to look long and hard to find a philosopher who was a prescriptive analytics philosopher, and I found one. His name was Yogi Berra. He said the future ain't what it used to be. Anyway, so I am out of time. I'm going to mention a couple of things instead of giving my next 45 minutes of slides. But the slides will be available, and I will be here to tell my stories. But loyalty in the context of data science has to do with data storytelling. Now, I recently did a workshop with Miko Yuck. Anyone who knows Miko Yuck, the founder of BI Brains, a BI world expert? Anyway, she and I did this workshop on data literacy, right brain meets the left brain. It was fascinating because I was telling sort of the data sciencey side, and she was talking about data visualization and data storytelling. And she said, what's really interesting is neuroscientists have studied this. What's active, the side of your brain that's active when I'm telling you the data, all right, is the left side of your brain. You know, the analytical side of your brain is all active and firing when you're hearing the stories, the quantitative stuff. But when you're asked to make a decision, all of a sudden, the part of the brain that's active is the right side of the brain. The empathetic, emotive side of your brain. It has nothing to do with the numbers. It's how you feel. If you read any quote from the slide, read Maya Angelou's. People will forget what you said. And you probably will forget what I said. People will forget what you did, but they will never forget how you made them feel. Or like this other person said, no one ever made a decision because of a number. They need a story. Okay, so if you're going to convert people and actually get them then to do this, okay, they've considered it, they're moving towards it, and they're going to actually do it, okay, that becomes that loyalty phase of data literacy. You got to get to that part of their brain where I hear your story. I want to do this. And I had stories here. Time's out for me to tell you the stories, but meet me in the hallway. I would love to tell you this story. You know, the internet is a lot like ancient Egypt. People write on walls and worship cats. I always started my freshman data science class to students who have one of these. They also have something else. They also carry some other baggage in that freshman data science class besides one of these. They carry this baggage that they hate science and they hate math and they hope there's no math in my class. By the end of the semester, I convert them to loving math and science such that they want more, because I say what you have in your hand is creating data, creating value. Everything you do and say on this thing, and track, whether it's geo-tracking or your pictures you post or social networks, someone's using that data to help your life better, to sell products to you and sell products to other people. Don't you want to be part of that market? Don't you want to be part of that career? All of a sudden, they're paying attention to me. Yeah, I want to do that. All right. So the most important V is the value that we're generating from the data. All right. So I can tell you a story about that, which I won't right now. I can tell you a story about that, which I won't right now. Please corner me in the hallway. I would love to tell you these stories. My most favorite one is about the most popular airline in Europe. Anyone ever heard of Transavia? It's the Southwest Airlines of Europe. Everybody in Europe knows what this is, but no one in America knows it. There's an amazing, absolutely unbelievable story of some person who was not empowered to do data analytics in their company, produced enormous value in a very trivial observation and data, which was made possible because the CEO of the company said, we no longer have front office and back office. If you see something in the data, say something. It's not someone else's job, it's your job. If you see something, say something. Where have we heard that before? Okay. Anyway, I'll tell you that story. So it's all about finally getting to this point where we have the advocacy. We have the data literati, the people who are advocates on the use of data in the marketplace for us. And my final quote, then I'll stop, borrowing from another discipline. But data scientists, people who work with data, even if you don't have the title data scientist, we're explorers, okay? Natural human thing, even as the school children illustrate, as we just talked about, as we learned a lot about yesterday. We're natural born explorers. Now, given this vast ocean of possible exploratory regions that we've never seen before, people want to dive in. They want to do this. And so this quote I found perfect for this. So this guy, Antoine de Saint-Exupéry, said, if you want to build a ship, you don't just like create a work breakdown structure and Gantt charts, drum up people to gather wood and assign them tasks and work and have a schedule. If you want to build a ship, what you do is you teach these people to yearn for the vast and endless sea. Then they want to build that ship. They want to do the hard work. They want to do what it takes to go out and explore. That's what we're teaching people, teaching them to tap into what they naturally want to do. They want to explore the world and understand the world they live in. So come for the data, stay for the science. Thank you for your patience.